Hello, everyone. It's great to be here again today. Good day, good morning, good afternoon, good evening, depending on which part of the world you are, hearing from. I want to thank you for joining yesterday. It's been a very exciting and amazing session. Yesterday was packed full of insights from our speakers, and today we have our second session and the final day. The theme of the event is accelerating innovation in architecture, engineering, and construction. And yesterday I shared the findings of a very staggering, you know, of a report by McKinsey in 2017. This report, the insight is very staggering, indicating that construction lags behind the entire world, as it were. Tech has experienced about 4.1% innovation in the last 2 decades. Manufacturing, 3.6% in innovation, and the global economy, 2.8%. However, our dear construction has experienced just 1% productivity in the last 2 decades. Now, this is staggering. This is staggering. And so this conference hopes to help to address how we can begin to close this gap in the industry. And so today we are starting our conference with the first session by Dr. Raul Del Toro. He is the Chief Operating Officer of Geometrica Incorporated USA, and I'm sure he'll be doing justice to the part of his own presentation. Thank you very much. Thereafter, I will have his bio. Thank you, and you're welcome.
Meet Dr. Raul Del Toro, who will be speaking on emerging technologies and innovations in construction. Dr. Raul's professional experience includes research in structural engineering, RC elements, and fiber reinforced concrete, Public Works Research Laboratory, Paris, France. Design of reinforced earthworks, the Reinforced Earth Company, Paris, France. Technical Director, Director of Operations, Incumbent, Geometrica, Monterrey, Mexico. His professional activities are centered in the field of structural engineering, buildings, and bridges. Led the design teams and participated in the fabrication and erection works for long-span steel structures in worldwide projects. He focuses on management duties and quality management for the design, fabrication, and erection of long-span steel structures.
Thank you. Thank you very much. Thank you for inviting me, and thank you to all those participating in this event. I work in designing and building steel structures, particularly long span and complex structures. And I wish to present to you today some cases of complex buildings that I have encountered in my practice of structural engineering. I would now like to begin the presentation. We will be spending some 10 to 15 minutes in this presentation. I'm sorry, can you see my screen? I hope you can see my screen now. We will be spending some 10 to 15 minutes in this presentation, which is structured on the following plan. We will see a brief introduction on the subject of complexity in buildings, centering on what I call complexity of shape. I will present to you some examples of complex buildings that I have encountered during my work. We will then see some materials and methods of fabrication that we have used to solve complex building shapes. And we will talk about prefabrication, precision, and the importance of dimensional control. I will then present to you the solution implemented to an actual building, and we will finalize this presentation with some conclusion on the subject. So let us now proceed with an introduction to the subject of complex buildings. Building architecture evolves continuously through the use of innovative designs and the use of new materials. And it is certain that this evolution results in complexity. Nowadays, buildings require many technologies in their day-to-day service, such as energy control, internal transportation, such as stairs and elevators, entry control, fire prevention, and many other technologies. An example of this complexity may be found in a commercial building or even an office building housed in a skyscraper. As may be imagined, the more complex the building in all aspects of its day-to-day service, the more specialized trades are required in the construction and operation of the building. Now, every work of architecture is certainly unique, since it embodies the architect's design ideas. Although unique, many buildings follow what we may call traditional geometric guidelines. Among these, we may mention regular shapes, like the ones we are seeing in the slide right now. It is a vertical building with a uniform facade. We may imagine that all the glass panes on the facade are the same dimension, of the same shape, of the same size. The building has a very traditional flat roof, and it is still a skyscraper. It still has all the complexity of technology involved in its day-to-day surface, but it has a very regular, very simple structural geometric shape. Now, we will be centering today on an element of complexity that does not arise from technical requirements or technology requirements, but one embedded in the architect's design. The element of complexity I am referring to is the shape of the building itself. In the examples that follow, we will see buildings departing from uniform geometries and creating many challenges, most importantly, fabrication and construction challenges that need to be solved in order for the building to be built. So let us now proceed to these examples. In this example, we see a building with a shape that does not fall within the typical geometric shapes. The geometric guidelines that we mentioned are absent, and this seems to be the architect's intent. That is what the architect wants to convey to us, a very complex shape departing from the usual geometric shapes that we use in buildings. We have a striking building, that is true, but with a rather complex shape. Now, looking in closer, we see that the shape of the building is complex in itself, but we also have a corresponding, also complex geometric arrangement of its facade. When we are faced with these designs, we need to ask ourselves the following questions. How are we to build these structures? Which materials are to be employed in order to make these designs a reality? And what are the available materials and methods of fabrication? We will answer these questions based on the use of structural steel, since, and that is my personal opinion, it is a much more simpler material to use than, say, reinforced concrete. Still, steel is indeed a very versatile material. It is available readily in various shapes and may be cut to size as required and joined together with other elements to form the required shape of the building's geometry. Now let's talk about fabrication of steel. How are we going to join the different members? Joining steel may be done by two main methods, welding and mechanical joints. Both methods are equally reliable from the structural point of view, but precision is generally critical to reach the required shape of a complex building, and achieving precision through welding is always a challenge. Welding is indeed a complex operation requiring skilled workmanship. The picture we see shows a very clean indeed welding job. It is the result of skilled welders. But it must be remembered that prior to welding, prior to reaching that result we are seeing on this screen, the ends of each member must be cut and shaped to join the surface on which they are to be welded. And this requires precision. Achieving a result such as the one we are seeing is difficult, it is costly, and it is time-consuming. We must add that most of the time, results such as the one we are seeing on the screen are achieved only in the shop. Welding in the field only complicates matters more. Now, as an alternative to welding, we have the availability of mechanical joints, joints that do not require welding. In the case of the geometrical system shown here, the mechanical joint is obtained using tubes with coined ends joined with an aluminum connector hub. Each tube is fabricated to specific length and end angles to form the required geometry. Each component is then packed and sent to the site to be assembled without any welding required. In a straightforward comparison between welded and mechanical joints, we may see the next slide where joints of similar geometry are shown side by side. The welded joint on the left shows excellent workmanship, while the one on the right, made with the geometrical system, achieves exactly the same purpose in structural terms in a simpler and much more economical way. The geometrical system is dimensionally precise and also provides for efficient dimensional control. Lengths and angles of each component can be verified on fabricated members, as shown here, and any deviations may be spotted and corrected. Further on, it will become evident that precision and dimensional control are very important, not only to reach the required geometric shape, but also to provide geometric information for other traits. So let us now proceed to see a real example of building complexity and how it was solved, walking from the start through the end of the building's construction. This is a general view of the building we will be taking as an example of a building's complexity in shape. I am not an architect myself, and I must confess I know very little about architecture, so I am not able to describe the building's shape in architectural terms. I did, however, once hear the architect of this building describing it as an example of what he called organic architecture, something approaching the shapes found in nature, distant from regular geometric shapes, and far from any symmetry in space. We see that the building in our example is not very large in dimensions. It is actually quite small, but it is highly complex in shape. This aerial view of the building does not provide us with sufficient detail, but we will later on see that the complexity of the building translates also to its structural framing and to its external and internal cladding. In this slide, we see the initial phases of the building's construction. Welded tubular members are curved in different directions and are welded to form the structural framing or structural skeleton. You may notice that the complex shape of the building requires also a complex structural framing. Indeed, we may see that not even the load-carrying elements that we see here at the bottom of the picture are actually neither straight nor vertical. We also see that at the top of the building, we have a compression ring being held in position temporarily with a propping tower. Once we have the necessary structural framing in place, we turn to the use of the geometrical system. Components of the geometrical system are assembled and erected between the framing members to form the surface that is to receive the cladding. At this stage, all structural elements are joined using mechanical joints. We then continue in this matter, installing members, installing components in order to obtain the building shape as shown on this view. At this stage, we are still not finished. We are very far from done with the construction of the building because the building still needs to be clad. Now, the cladding itself is made of glass panels on the exterior of the building and marble panels on the interior of the building. Note that each panel is triangular in shape but is different from its neighboring panel. All dimensions or angles, all lengths are different. Each panel must be fabricated to precise dimension. It here becomes evident that the precision and the dimensional control inherent to the geometrical system is very important, since it allows us to determine the dimensions and shapes of every cladding panel that will be fabricated and installed by other trades. These are two outside views of the completed building. On the left, we have, once again, an aerial view, and on the right, a detail that clearly shows the complexity of the building. On the detail on the right, you may notice that while triangular glass panels are used over a large percentage of the surface, the design also requires that along the edges, we have curved glass panels, another element of complexity of fabrication of installation. Next, we will see an inside view of the building's cladding. It shows the internal cladding made of marble, as I told you, reaching up and twisting towards the compression ring and blending in with the different skylights and windows. The results, in my opinion, are visually stunning and demonstrate that even a building with a complex shape, such as the one we have seen, may be solved with the use of the geometric system. We will now close this presentation with some conclusions. We may conclude the following. First, complexity is ever present in architecture, and more nowadays, with a tendency to build in skyscrapers, with a tendency of architects to build complex shapes, with the availability of new materials and fabrication methods. Also, complexity of form may be solved in several ways, in various ways, with different materials, with different fabrication technologies, etc. One of these ways of solving complex shapes that is both feasible and economical is the use of steel and aluminum to form mechanical joints, such as the ones in the geometric system. Finally, dimensional precision is required to achieve acceptable results and to collaborate with other trades. Here, I have reached the end of this presentation, and I thank you all for your attention. Thank you very much.
Meet Dr. Obi Uwakony, who will be speaking on digital transformation in AEC, architecture, engineering, and construction. Dr. Obi is a highly motivated and creative architect with 25 plus years of extensive experience in planning, designing, and construction. He holds a PhD in using computer-aided architectural design, CAD, in education. He is a passionate educator and has mentored hundreds of architects on using digital technology in architecture. He is a consulting architect and the principal partner of Wazak Building Workshop Limited, with an extensive clientele spanning private, corporate, state, and federal government projects.
Good morning, good afternoon, and good evening, everyone, depending on where you are. My name is Dr. Uwakony, and I will be speaking on digital transformations in the AEC industry. And my focus will be on digital twins and their impact on the construction life cycle. I will also be speaking on workplace adaptation and skill development, And also, I'll be speaking on data-driven decision making using big data analytics in the construction processes. Today, we gather under a theme that couldn't be more relevant: design plus technology, accelerating innovation in the architecture, engineering, and construction industry. This theme is not just a tagline, it's a declaration of a movement that is really transforming the very foundation of how we architects and engineers imagine, shape, and deliver our built environment. Let us step back for a moment and consider the world we live in. We know that innovations have challenges are the drivers of innovation. So wherever you see innovation is a result of an existing challenge in that area that necessitated the innovations. In the world today, we are faced with complex challenges. Look at rapid urbanization, climate change, housing shortages as a result of population explosion, aging infrastructure. These aren't just issues that can be solved by design or technology alone. But when design and technology converge, when human creativity meets digital intelligence, we unlock transformative power. In the AEC industry, this convergence is happening everywhere. Everywhere you look, the industry is at a pivotal moment. You know, for decades, we've relied on traditional methods in delivering our projects. However, digital technologies are fundamentally changing the narratives. It's changing how we design, how we build, and how we manage our projects. Now, looking at digital twins and their impact on the construction life cycle, we need to know that digital twins are dynamic real-time digital representations of physical assets, systems, or processes. In the AEC industry, they actually simulate buildings or infrastructure across their life cycles, from design through construction and operations. And simply put, they are just visual models that mirror physical structures in real time. And it allows us to simulate and test different scenarios, and also to be able to improve and extend the life cycle of the assets. Digital twins can be applied in design, can be applied in construction, and it also can be applied in the operation phase of the project. We need to look at it one by one. Now, in design phase, it can be used to enhance visualization. Here, architects and engineers can simulate design in real time using 3D and 4D models. And it also helps in better decision making by designers. And it's possible for architects to evaluate options with greater accuracy, you know, by simulating how design changes affects energy use, costs, structural performance. If you are designing a house, once you start applying changes in your design, selecting certain elements, you can interrogate it further in order to help you to make better decisions in terms of your design. Also, it helps in improve collaboration between stakeholders, clients, contractors, and being able to use a data-rich model to interrogate a building projects properly, and in order not to make mistakes during construction, which might result in cost overruns as a result of um, scheduling issues and challenges. Because when you stop as a result of a mistake that has been made in the construction phase, it means that further things that has to be done on the project will wait, and it might have cost implications that might be massive. And it was not actually factored anywhere in the cost and estimating of that project. In terms of the construction phase, digital twins can be used in real-time monitoring, can be used to integrate, it can be integrated with sensors and Internet of Things devices in order to track on-site activities, progress, and safety conditions on the site. And it can also help in tracking quality assurance in terms of deviations from design and actual construction are detected early in order to reduce rework. And also in resource optimization, it can help in planning and sequencing tasks efficiently, reducing delays and materials waste. In the operations phase and maintenance phase also, digital twins can be used for predictive maintenance. Systems can forecast component failure. Example, in your HVAC before it happens. Saving costs and downtime. Because in the course of operational phase of the building, you will notice patterns that you can use your digital models to be able to predict your maintenance and schedule it properly. Also, in facility management, the digital twins can serve as a life reference model for managing utilities, space, and occupancy. And also, it can be used in energy efficiency in the operational phase of the building. In renovation and decommissioning of a building during its life cycle data archive, digital twins can be used to maintain an up-to-date record of the building's history, modifications, and systems performance that will help in terms of planning retrofits. If there's any need to change the building into some other use, what has taken place in the building that might not be visible to the physical eyes, the digital models can be able to situate it properly. Engineers can simulate retrofit impacts before physical implementation, and it can also help in waste reduction. Being able to have accurate data, it will allow for better material salvage, recycling, and rest. Now, I want us to look at practical examples of digital twins. First of all, we want us to use New York City, the digital twin on New York City. It was created for the Spider-Man movie, and it's very interesting. New York City is not just a backdrop in the Spider-Man films. It's just a living, breathing character. You know, it's just to realistically, depict Spider-Man, or his swinging between skyscrapers or engaging in high-speed chases. The filmmakers, they needed an extremely accurate and interactive digital replica of the city. And as a matter of fact, when they were making that movie, the mayor of New York was worried because the process was becoming a nuisance in the city. The way the directors and the crew were moving around, they decided, oh, they can't do this thing again. So that was the very reason why they decided to go for a digital model of the city to use it for making of Spider-Man movie. Now, the key objective by the by the movie makers is to be able to simulate real-world physics for web slinging dynamics. To be able to create seamless visual effects during complex action sequences, and also to allow for creative freedom while retaining architectural and spatial accuracy. Now, while digital twin of New York City, it was primarily created for entertainment, but it has opened our eyes that in AEC industry, it can adapt to similar techniques, urban planning, to test infrastructure projects with digital things, and also for emergency responses, simulations. Example, for disasters, you could use detailed city models to be able to do that. Now, we need to come to terms that smart city systems it can visually visualize sensor data in real time within such environment. This digital twin for New York City, for Spider-Man, it demonstrates the incredible power of merging design plus technology to replicate, simulate, and reimagine urban environments. What started as a tool for entertainment is now influencing how we build, manage, and experience real cities. Like in other examples, as we have here, like Singapore Smart Nation and Visual Singapore project. The Singapore Land Authority decided to embark on a groundbreaking project to create a digital model of the city. You know, this is known as Virtual Singapore. It involved the use of cutting-edge technology to develop a high-detailed 3D representation of the entire island nation. Now, the project involves a 3D digital twin of the city, integrating real-time data, and enables urban planning, traffic simulation, environmental monitoring, and infrastructure maintenance. Architects and engineers can assess and test design impact before physical implementation. Now, another example is city of Amaravati in India. Is the proposed new capital city of India. It planned as a smart city, and they developed a digital twin to monitor construction progress, test environmental effects, and optimize infrastructure delivery. Now, all stakeholders from urban planners to contractors can access a unified model for their aspects of the project. We also need to look at the Crossrail project in Elizabeth Line, UK. They also developed a digital twin. This is one of Europe's most advanced infrastructural projects, and they use digital twin for it, simply for asset management and operational planning. And it helped them to simulate maintenance scenarios and avoid failures. Now, the overall benefits of a digital twin in the construction life cycle is increases efficiency, safety, and sustainability, and it enhances decision making with real-time analytics. It reduces costs and delays across project phases, and at the same time, it bridges the gap between physical and digital in the built environment. Looking at workforce adaptation and skill development, the digital transformation in the AEC industry, it demands a workforce that is skilled in BIM, that are skilled in data analysis, and are skilled in automation, and are skilled in AI-driven tools. We need to come to terms that upskilling is critical in order to bridge the gap between traditional methods and tech delivery processes. However, technology is only as effective as the people using it. So the workforce adaptation becomes a top priority, especially in our climate in Africa, where digital skill gaps still exist. We need to also come to that tools evolve fast, very fast. And in our industry, if you blink, you miss. So training is essential to keep pace with advancements in digital technology. In skill development, BIM and generative design, they are helping us to go beyond just visualizations. They are now tools. These tools, they don't just show us what buildings will look like today, but at the same time, they can help us to optimize structures for energy efficiency, for material use, and for sustainability purposes, even before you hit the ground running on the project. And also on the construction side, robots, drones, and artificial intelligence, they are taking over most repetitive, risky tasks. No, they are not going to replace humans. What they are doing is just to augment us in order to enable faster builds, safer environments. In fact, these tools are supposed to be our design assistant and our construction assistant. They're not replacing anybody. But here, we need to know the heart of it. Technology is not the driver. People are design thinkers, technologists, site engineers, clients, community members. Now, the magic happens when we blend deep technical capability with human-centered design. Because innovation isn't about gadgets or algorithms. It's about creating better outcomes for people. Of course, this transformation that we're talking about, it also calls for a new kind of workforce. A workforce that is agile, a workforce that is digitally fluent and collaborative. Now, upskilling is no longer a luxury, for professionals in the AEC industry. It's a necessity now. In whatever area you are, it's a necessity. Around the world, we are seeing major efforts to empower architects and builders with tools like BIM, virtual reality, cloud collaboration platforms, and data analytics. Now, we need to look at practical examples of workforce adaptation and skill development. We need to look at the examples of Toro Construction. Toro Construction is a big construction company in US. They launched a digital literacy program to train their staffs in BIM, virtual reality, walkthrough, and construction tech platforms like Proco. And this resulted in improved communication and fewer site errors. Also, another practical example is Autodesk. Autodesk and the African Academic Partnership. I must say here that I am a beneficiary of the Autodesk African Academics Partnership in training resource persons to be able to train others. It is called Train the Trainer program. They partnered with universities in Africa to offer AEC design and BIM certifications. And in some of the universities in Nigeria, that's the norm now. From 200 level, future professionals are enhanced with digital skills, that will lead to industry transformations. Now, Lengorock UK is another big construction company in UK. They developed an internal digital engineering academy to train over 500 employees. They train them in BIM level 2 compliance, and also in the use of robotics and prefabrication tools, and also in cloud-based collaboration platforms, which means it's very, very important for you to train your workforce to be able to adapt and be able to stay ahead of competitors because as day goes by, new innovations are coming up, and if you're not on top of your game, you might not be in forefront of the global best practices in your industry, and you'll be losing your clients and businesses. Now, key takeaways from workforce adaptation and skill development is that upskilling, it enhances productivity and project delivery speed. At the same time, adoption of augmented reality and virtual reality tools for immersive training is important. Now, digital savvy teams to reduce rework and improve quality. Now, there has to be future-ready workforce that should adapt to technological tech adoption. Now, looking at data-driven decision making using big data analytics in construction. This involves using structured and unstructured data, from sensors, from drones, from wearables, from Internet of Things devices, etc. Construction firms can now make informed decisions on safety, scheduling, resource allocation, and design optimization. Because in this profession where we belong to, data is everything. Data can make a lot of differences in anything that you're doing. Now, imagine combining sensor data from your site, drone footage, and materials tracking into one dashboard, maybe in a boardroom. Imagine a company that has a construction site in Lagos, construction site in Abuja, construction site maybe in New York, construction site in Port Harcourt, another construction site in Dubai, and being able to sit in the boardroom of the company and be able to access information that has to do with each of those sites and be able to make better decisions and take decisions by the major decision makers in the company, and be able to track performance of their on-site personnel to be able to know whether they are moving according to the vision and goals of the organization. Now, the sources of data is from Internet of Things sensors, from drones, from wearables, and then from construction softwares. We're looking at practical examples of data-driven decision making. We need to look at Mortensen Construction. It's one of the top 20 construction companies in US. They use big data from Internet of Things sensors on job sites to be able to monitor their equipment usage, worker safety, and material flow. It's very, very important. And now they were also able to use it for predictive analytics that help reduce equipment downtime by 20%. Look at also Skanska. Skanska is another big construction firm. It integrated AI and image recognition software to analyze job sites, photos, and videos. And he also used it to identify safety risks. Example, missing personal protection equipment and reducing incidents by 30%. Now, another practical example is China State Construction. They use real-time data from drones and artificial intelligence-powered surveillance to track construction progress and detect deviations from design. And they also use it to accelerate project timelines by 15 to 20% through data-driven adjustment. In terms of the applications of data-driven decision making, you can use it to forecast cost overruns. You can use it to optimize workforce allocation. You can use it to enhance supply chain management. You can also use it to reduce risk via real-time insights on your project sites. And then some of the benefits are cost and schedule forecasting, and also risk reduction, and also be able to enhance site safety. Now, looking at design plus technology, in terms of shaping the future of the AEC industry. Where do we go from here? We need to come to terms that we are at the cusp of a revolution, where design is no longer just about form and function, but about intelligence, responsiveness, sustainability, and above all, integration. The question we must answer, even as we leave this conference, is what does the future hold for design? What does the future hold when design meets technology head on? Now, the fusion of design plus technology in architecture, engineering, and construction is no longer an experiment. It is a movement. It is giving rise to responsive buildings, data-driven infrastructure, and collaborative ecosystems. Now, let's envision a future where a building adapts to its users in real time. Cities self-regulate their energy flows and waste system. And every design decision is validated against decades of performance data within seconds. This is not a sci-fi movie. This is the future of the AEC industry. And it's already unfolding. What does it mean? What does this mean for architects and designers? We as architects and engineers, we must embrace a new identity, not just as form givers, but as system thinkers, technologists, and data translators. That's what we are. That's what we do. The tools of tomorrow will not replace creativity. They just amplify it. But with this power, it comes responsibility. We must ask critical questions about ethics, accessibility, and inclusion. I was having this conversation with my PhD students a couple of days back. We must design not just for beauty, but for equity and resilience. We need to look at Africa's opportunities in this revolution. We need to bring this thing back to our climb where we are now. For us in Africa, this transformation, it presents an opportunity not to follow, but to lead. We need to start engaging our government. We need to start trying to make our government include laws that makes this phenomena, a law in terms of the professionals should be neck deep in the use of these tools in the delivery of our project. Now, with rapid urbanization and a young tech-savvy population, we can actually leapfrog legacy systems and embrace smart, sustainable development that reflects our realities. Should be able to design buildings that speak our culture, meet global standards, and are digitally intelligent. Now, my closing thoughts. The future of design for technology in the AEC industry is not just a distant dream. It is being written by those of us, by me and you, that are willing to think boldly, collaborate courageously, and innovate relentlessly. As I close, and as we leave this conference and return to our studios, our sites, and our boardrooms, let us not ask what will technology do to our industry, but rather, what will we do with it? Let us build the future intentionally, intelligently, and inclusively. Thank you. Thank you.
Meet architect Tola Oyenuga, who will be speaking on Smart Design and Construction Arc. Tola Oyenuga is the Deputy Head of Unit Architecture at PrimeTech, with over 15 years' experience in the field of architecture. He holds a BSc and MSc in architecture from Covenant University. He is a full member of the Nigerian Institute of Architects, NIA, and a fully registered architect by the Architects Registration Council of Nigeria, ARCON. He is also a professional energy auditor with experience in sustainability and energy efficiency in design.
Good day, everyone. Yeah, thank you. Thanks, Dr. Benga, for inviting me to this program and for the nice presentation by everyone and also the team behind the Just Design. Today, I'll be taking you through some snippets of smart design and construction, focusing mainly on building the future with intelligence. A lot has been said about smart design, but I'll take you through what I consider the backbone of smart design and what essentially we get to enjoy at the tail end of the design process and the actual smart buildings that people are getting to be familiar with. Okay, so imagine a building that breathes, adapts, and learns about its environment and improves with time. That's the promise of smart design and construction. Before now, buildings were usually designed and constructed for peak performance. And then throughout the year, it's managed, or if you're not comfortable at the other times of the year, you change your environment, you change your activity because the condition in those buildings are no more conducive based on the season. But with new technologies, with advanced knowledge, we are able to design more in a more fine-tuned and granular manner for the environment we are in, and that starts with analysis. So today, I'll take you through understanding energy flows in building because as building interact with the environment, they're essentially interacting with different energy flows. And then we will look at smart design principles and tools, look at the construction process and the constraints being experienced currently, and looking into the future. And during the panel session, we take questions. Okay. Yeah. So starting with understanding energy flows in building. The image on the top right shows a typical cross section across a building with an occupant. And what we experience indoors is the heat that comes from the sun, the light that comes with it, and ventilation through the openings. And this um, energy flows. To design smarter, we need to understand that energy enters the building, moves around, and leaves the building. As it moves around the building, the natural energy is converted from heat and light into the building and are trapped in the envelope. But what we experience is putting in mechanical means to make the indoor environment conducive. And that's just one form of energy being transferred from one to the other. We know in thermodynamics, energy can either be created or destroyed, but can be transformed. And that's exactly what is happening. In the end, what users know, especially homeowners, is how they interact with their how they interact with energy is with their pockets in that they pay for these energy bills. So understanding the energy flows will make for a better design that situates the building in its context and reduces first the energy required to keep out the environment, and then go into selecting energy efficient strategies in optimizing the active components. And after that, when those systems, when energy use is reduced, efficient energy strategies are implemented, then you can look into renewable. If you start from just sizing renewable energy for your project without making the envelope efficient, you end up oversizing your active components, and that would invariably lead to more cost for the client, which won't be efficient. So, what is smart design? Essentially, this is um, when a building is able to vary its state and react to the current condition in the environment. That's what makes a smart design. So the building itself is not static. It's not in its ninth year. It's not behaving as it was in its first year. It's adapting to whatever temperature, light is available, and making its occupants comfortable for that season. Not just a static calculation made at design and constructed the first time. So smart designs integrate building physics technologies and data, which is important in this case, to create structures that are energy efficient, adaptable, and occupant focused. And in that, it makes the it improves the sustains the health, improves the health of the occupant. It also ensures their comfort in that at the tail end of the smart design and the actual building, you have tools, you have buttons you can use, the occupants can use to interact and modify their environment in a comfortable manner without exerting much manual effort. And this matters because implementing smart design can reduce operational costs by up to 20 to 30% over business as usual, according to the US Department of Energy, and 40% according to Building Energy Efficiency Code. That's the code developed by the Ministry of Housing and Urban Development with the help of with collaboration with GIZ. Yeah. So they studied buildings around the country, residential and official, and defined strategies for passive and active means of energy efficiency. And from their test, if you employ that in your building, that would consume 40% less energy over business as usual for an energy efficient building. Smart building goes further in that after the building is already energy efficient in terms of design and contextualization, in operations, by employing these smart design technologies, you are able to, or the building is able to, even at a granular level, react at a final level, cascading down its energy consumption and reducing further than the benchmark 40% we are seeing here on the screen. And I'll show you with the Prime Tech Office example where I work. Okay. And so it has the comfort and productivity we mentioned earlier. And then invariably doing this aligns with sustainability goals and regulations. And some of the components which we are familiar with are the Internet of Things enabled entertainment system, the daylighting controls, window blind controls, smart meters, batteries, solar PVs, and things like that. And one thing that is happening in the future in some other places are already looking at the smart grid. As buildings, individual buildings, residences, commercial are getting smart and efficient, they're looking at the grid itself where the energy is being produced. So when all these things are connected on the smart grid, the grid is able to push energy to exactly the end users that require it or where there is a gap. So if your house is producing more solar panels, solar energy than required, your house will be a net contributor to the grid. You will earn credit or earn money for that, whereas the end user down the line that needs it gets more power at that point. So from what it is, let's look at the process flow of smart design. Starts with understanding the context and carrying out climate analysis. On the top right, you have an example of a psychometric chart of Port Harcourt, and every blue dot you see is an hour of the year. There are 8,760 hours in a year, and the green zone is the thermal comfort zone defined by ASHRAE 55. So all the dots you see in the green zone shows you how many hours of the year a space that is ventilated with the minimum required by the code for an occupant wearing um, CLO level 1, no, 0.5 for summer, which is our own environment, how many hours in a year they will be comfortable. And this shows that only less than 5% of the year is comfortable in this space. In order to move the design strategies required to move all the blue dots down towards the green zone will be dehumidification and cooling. So analysis like this taking over the year would enhance the ability of designers to fine tune their design. Because if it's a school, for instance, schools are shut down during summer holidays and all that, you can see the patterns of, like you see the temperature range below. You can design your HVAC system such a way that when it is not required, the the whole system is shut down. And because of that, you might find out that your peak load, which is normally what is designed for, will be lower because you're concentrating on when it is required and what your environment calls for. Once you understand the climatic condition, looking at the climate, the solar study, and all that. Next is optimizing the passive component. The passive components of a building are the envelope, the walls, the facade, the roof, and all. Then you choose the right, test different options, and then choose the one which shuts out the heat as much as possible. If you need insulation in the wall, this is when you test those parameters in simulation, energy simulation, and then choose the optimum solution. What is known currently is that little insulation is better than no insulation because it's a big, significant jump from having minimum insulation to not having insulation at all in terms of energy consumption. And once the passive design strategies are implemented, you then look at active components, which are the lighting fixtures. You pick high efficiency fixtures, LEDs and co. Look at the HVAC system. You pick high efficiency, low COP, no, high COP, that's coefficient of performance in HVAC systems, because for every unit of energy going into the HVAC system, they are able to produce more cooling on the other side because we need cooling in this region. So that's how you pick active components of HVAC. Also, in the HVAC space, there's the possibility of of using variable speed drive. So instead of sizing a pump to just run 100%, the variable speed drive will run the pump to the demand at that point, thereby pulling energy to power itself only for what is required. And then when you're done, you implement sensors and smart meters which are all controlled by the building management system in order to give you ongoing measurements beyond just commissioning and construction. Then you're able to see how the building is actually performing and if you need to react, if you need to augment something or fix. And it's also used for maintenance. And lastly, are the active controls, which you see, which is what is widely known, like pressing a button on your phone, one app to shut down your whole light. Maybe you're traveling for on holiday, one button shuts down the complete building, and you don't have to go through each room or each space to control that. Also, you have you can control blinds, you can control visibility of glazing, all that, and that it's highlighted because all that is not the background of smart design. The actual smart design comes from contextualizing the building itself and designing for passive and active means. Monitoring and then layered on top the BMS and all that system is the controls for the comfort. But without the efficiencies designed into the project, the active controls will just be an efficient way of being inefficient. So here on the left, you see passive means during the analysis of the Port Harcourt project, there's, according to ASHRAE, for shading to be required, the dry bulb temperature has to be more than 26 degrees and global horizontal radiation needs to be more than 316 um, yeah, kilowatt per square meter. So looking into that and overlaying it with the sun study, we get a sense of the portion of the building that needs to, you can't see the building in this, but that's part of the analysis. That this is how you analyze which glazing needs to be shaded, which facade needs to be shaded. And as we can see, according to this, the sun moves over this north and south of the country for every year. So the common knowledge is shade your windows to the south, but actually half of the year the sun moves over the north. So if you neglect the north and you don't, you would also lose efficiencies on the north side and not glazing. Okay, you have active components on the right. And one other interesting part of the HVAC component is the possibility of heat exchangers. So you have cold air, let's say fresh air, you pull in fresh air into the building, you cool it down, and then once it's done for 100% fresh air system, you exhaust the fresh air. But in systems like this, when the air is coming in from the environment, it's coming in at say 35 degrees, and then you use energy to cool it down. The water chiller is maybe running at 6 degrees, you cool it down to 24, push it around the building. When it's done, it's exhausting, you're exhausting at maybe 26, 28. But what you can do in this component is it can pass the flow of the air without mixing the air beside the new 35 degrees incoming fresh air before it's cooled. So it will cool by conduction in this plate naturally before you need energy down the line to cool it further to the 24. This component alone can save you 40 to 50% of the energy consumption for cooling. Strategies like that help in achieving an energy efficient building. So these are just examples of what you need to do in each of the phases. And um, the next step is looking at the tools you need to employ in designing smart. What we've noticed is essentially it's information, all the smartness in the design is information and intelligence moving from one platform to the other. In analysis, you use different software, different platform, Excel calculators, different things online, offline. And then in the construction space, you AEC, you use Beam and the other tools. So Revit is one of the tools that enables 3D design and collaboration. Navisworks, on the other hand, can be used for clash detection, and then you can layer on your 4D, 5D for scheduling and cost planning, which is essential down the line for construction. And as all this information is moving from one platform to the other, one stakeholder to the other, one good thing to keep in mind from the beginning is to implement something like a unit class. This is a classification system that helps in labeling components in design. So across the whole design phase, things would be labeled correctly, and designers will be able to use those components, pull out the information they need. Down the line, when it gets to facility managers, they're also able to use the same information. One building element that has the right classification, and different professionals are able to use the same information in their own tools down the line. So here is a view of one warehouse we did in Bonny, and here is a view from Navisworks, uh, checking all the components, structural architecture, MEP, uh, the PVs, everything, checking that for clashes in Navisworks. Okay, so now when the smart design is finally done, coordinated, and it's time for construction. There are practices the construction side need to keep in place, keep in mind to ensure that the whole design is constructed correctly. And these are digital tools, digital technologies. You have drones where you can survey, get more fine-tuned uh, and information at a granular level, put that into softwares, Navisworks and the likes, and get out the information correctly for designing. And Theodolite, when design is done, you can take that BIM model, put it in a digital in Theodolite, and you can set out your building automatically without taking papers around for setting out and things like that. And it helps decision making. You've all heard about robotics and automation from other speakers, and this tools and practice also speaks to QA/QC. Those Internet of Things sensors can also be used during construction to monitor strengths in the structural element and adjust and ensure that it's being built correctly. You have AR, VR, you see in other sections. And for project management tools, you can also pass those information through cloud-based systems, be able to monitor, utilize lean construction, commission, transfer as built documentation, all the way at project closeout to um, management to facility management. At the facility management space, that BIM model can also be used. This is an example, an image, view of Autodesk Tandem, which is now being used by facility managers to pull data from BIM. You can use it to schedule maintenance, also plan for preventive maintenance and the likes. There are constraints in terms of initial cost. And one thing to note is to sell this, you have to show and quantify in analysis the savings to the client. So the client says, in paying this initial cost, down the line, I get to save 40%, 50%. The International Finance Corporation checked some green buildings over a long span, more than 5,000. And what they found out is that averagely, the incremental cost of going green is between 3 to 7%. So it's actually not as scary. If you ask anybody, they will ideally say 30% increment, but it's not the case with actual building constructed. So convincing with data and analysis is what can get clients across the way. Dr. Binga also mentioned the gap in that there is only 10% to 20% of AEC professionals or firms in Nigeria utilizing BIM software. I think we need to push that statistics to go up, because the rate at which information is expanding, and these are the tools that can help condense that and use it efficiently. Okay. The image on the bottom on the left shows us what happens to conventional buildings and energy efficient buildings over time. Essentially, smart buildings is that long term you reduce the cost of operation and CO2 emissions in the atmosphere. And above it, we have the office building actually for prime tech. Over designed, as in over the design state, right now we are consuming less than 75% of business as usual and less than 66% of um, the design state of the building, because the sensors in the BMS, we fine-tuned it as we saw feedback from users. Initially, it was designed to 18 degrees, but people were wearing jackets and all that. So we raised it gradually to 24, and no one noticed, no one complained. Everybody was fine. With that, we got more savings down the line in our energy bills per month. So in the future, because information is expanding, AI and machine learning is what can cope with this expanding information. And what you will find is that analysis and heavy manual items would be getting more automated. Instead of calculating a lot and using softwares, because of AI agents, you would only be prompting these tools to run the analysis behind. Softwares would be condensing and collapsing into each other. And then you'll be able to use one tool to reach out to all the tools behind with agents and get out the design and information you need on the other side. And as IoT is expanding, we'll be able to granularly take more readings in the smart space. In terms of right now, you can take one sensor can sense if there's occupant in the room or not. But in the future, you'll be able to take more readings, like what is the actual activity level of the individual. Is the person sitting? Is it jogging? Is it actively moving around the space? So you can fine tune the system, can change the cooling demand for that room as required. Okay, and sustainability will be the norm. So thank you very much for listening to this, and I hope you enjoy the rest of the program. Over to you, Binga.
Meet Folakemi Odesola, who will be speaking on Smart Homes, Smart Interiors, Designing for the Connected Lifestyle. Folakemi is an interior-exterior spatial designer with over 15 years of experience in the building and design industry. She holds a BSc and MSc in Architecture from Covenant University, a diploma in interior design from Regent Academy, UK, and is currently pursuing an MSc in Construction Engineering Management at the University of East London. As CEO of Adeline Signature Designs, with projects that span building and interior design, furniture, and landscape services, she leads a passionate team in crafting holistic spaces that support clients on their journeys of growth, intentionality, and conscious living. ASDL believes that buildings and their environments hold untapped potential to address emotional, psychological, cultural, and self-care needs, with design being a soulful tool to bring both life and business dreams into reality. Meet Folakemi Odesola.
Hello, good evening, everyone. Can you hear me? Just put in the comments if you can hear me. Okay, thank you so much, Tola. Thank you to the Just Design team and to Dr. Benga Alalade for inviting me to do this presentation. It's going to be, I hope that it will be a beautiful next 15 minutes. I'm also grateful to the rest of the people who have spoken before me, to Dr. Obi, to Arc.Tola Oyenuga as well. Thank you, Arc.Tola, for breaking down the technical part of all the things that I'm going to talk about. As Arc.Tola has broken down the technical part, I will just come from the human-centered view or the human-centered point. So please, can I have the next slide, please? All right. So, okay, we've talked about who I am already. I'm an architect, designer, creative design mentor. Next slide, please. I also am a coach, speaker, and I mentor architecture students because I have a passion to see people really understand the concepts of design and understand, the rudiments of design and design better spaces that are more human centric, better spaces that talk about, interpret people's identity, authenticity, influence their behavior, and actually preserve that identity. Next slide, please. I'll be speaking to us today about smart homes and smart interiors. Can I have the next slide, please? All right, so smart homes and smart interiors. That's what I'm going to be talking to us today. So I'm going to first define what smart interiors, what does it mean? What does a smart interior mean? So this is a design that is enhanced by technology. It's responsive, adaptive, and very user aligned, psychologically, emotionally user aligned. A smart home is a living space that is connected. It has interconnected devices that automate and optimize daily tasks. So for people, as designers, as architects, engineers, construction professionals, designers, industry designers, our main goal, with smart interiors or with smart homes, with all the interconnected devices that automate and optimize daily tasks, is efficiency, comfort, and identity expression. Next slide, please. One thing that Dr. Gbenga Lalade mentioned yesterday, he talked about the fact that the AEC industry is a little bit slow in adapting to, a lot of the new things that we are seeing, a lot of the forward movement we can see in the tech industry and in a lot of other industries. So smart homes, the interior industry, I think, is a little bit more. Should I say is bolder, is a little bit bolder. Things are changing. We have things that are, innovation. Let me say we have innovation within that industry. So in smart home technology, we realize that things are actually moving forward and things are changing. And we'll see that when we look at the history of smart homes in a moment. But for now, smart homes are actually powered by the Internet of Things, right? It has sensors, AI automation, and these are the things that enable interconnected devices. Next slide, please. Like thermostats, that help us to, then security systems as well. And these things are managed by centralized hubs. The main players in the industry are Google and Amazon. So you have Alexa, you have the Amazon Echo, and you have the Google Nest or Google Home. And those things allow for these tools, these devices allow for voice interaction and for audio playback. We also have AI assistants okay, so the newer versions of these Amazon and Google tools allow for data analysis, right? So they learn the habits and preferences of the residents of the buildings where they are. And they now start to regulate things, start to influence things based on the data that they have captured. We have things like, scheduling your music. You can schedule to listen to a podcast. You can schedule your to do list. You can say, when I wake up in the morning, I want to listen to a particular audiobook, and things like that. So these AI assistants help to learn the habits and the preferences, the values of people who live within these buildings. And then it now uses that to make the building more optimal for the users. There's also energy monitoring, tracking and reducing the usage of energy. And this is good for sustainability. There's efficiency and there's cost saving. There are also smartphone apps. So within your smartphone, you can actually go out and control uh, the things, the happenings, things that are happening within your environment, and you can monitor devices. So, for example, you go out and then a client goes out and forgets something is switched on or left on, in the house, and they can actually switch and control things from wherever it is that they are. There's also geofencing. Geofencing is when, based on location and proximity, some automatic features, begin to happen, in the house. So, for example, you get to your gate. I remember our cyber tech professional talked about something similar yesterday when he talked about the fact that they put in some smart features, and when the camera, the sensor, when it reads the plate number, the access gate opens up, for the occupants of the estate. So it's also very similar. We can have things like that within the house as well, based on proximity or even scanning, sensors and geofencing. Geofencing is basically, the difference is that geofencing is basically based on location and proximity, and then the other one, which is the sensors. That one is based on, detecting through physical input. So for example, it could be motion, it could be speech, it could be, clapping your hand, or something, or stepping into a space, and then the space is controlled. Next slide, please. And so let's look at history of smart homes. Uh, I'm sure you can see the first model of what was thought to have been, what was designed to control a smart home. This is called the Echo 4 system design, and it's in the Westinghouse electric engineer. It was a Westinghouse electric engineer named Jim Sutherland, and this was around 1966. So he built this mainly to control, different systems, within the house. So this is exactly how the system look. Look at how bulky it is, and this just tells us what innovation has really done in the interior design industry. Things are smaller now, they are portable, they are efficient. Next slide, please. And I mean, it's not as bogus. You don't need to build like an entire extra room or extra space in your house just to be able to have this running, right? So we also have, so that was the history, right? That was when it kind of began. And this is now, the future, not the future. This is now. Let me say this is now. This is today. We have people like Bill Gates, who is a very big player, in the industry, in the tech industry as well. He has a home that is called Xanadu 2.0, and Bill Gates' home. It's not just about tech for Bill Gates. This house is really adapted to his personal lifestyle, not just lifestyle preferences. So his personal lifestyle and his preferences. So, in his home, he has things like artworks on the wall that can change with the push of a button. So the home itself is actually integrated into the compound. Imagine a sort of falling house, by Frank Lloyd Wright, something like that. But this is also a home integrated into the environment. But it's integrated into the environment and built so that there are some smart features built into it to help regulate temperature, more efficiently. So he has artworks on the wall, like I said, that even the visitors are open to using those features. So they give them like pins or something, and when you come, you can decide the kind of music you want to listen to. So when people come to the home and we say, "Oh, what would you like to drink?" Just look at the bar and take what you want. So this is also like a look at the bar situation, where he says, "Oh, this is your pin. You can decide whatever music you want to listen to." His home has other features like sensors in the floor that detect the weight, of people. detect the weight, how heavy is this person, and based on input, so data analysis and input, things have been, so the house knows the occupants, the primary occupants of that house. And so if there's somebody with as little as a difference in weight in that house, the house picks it up. Right. And then the house also has systems for watering Bill Gates' favorite tree, things like that. So this is not just design and technology, this is also luxury. So this is an example of a home that is built to the taste of and the preference of the owner. Next slide, please. What does designing for modern people mean? Because the focus of today's conversation is actually designing connected spaces, designing connectivity for modern people. How do we design for modern people? We have to first of all define modern people. Who are modern people? Modern people are people like you and I, tech enthusiasts, people with allergies, normal, everyday allergies, normal problems. Some people are disabled and some are differently abled. You have professionals who work in the office, you have new parents, you have parents trying to build environments that not just influence but optimize and their lifestyle, make it more efficient, for the kind of things that they are involved in. You have children, you have old or aged people, you have creatives and designers, architects, engineers, consultants, construction consultants like you and I. And so these are modern people. Now, if we take into next slide, please. If we look at it and say these are the people who are modern people, then how then do we design for modern people? It means that it's not just about gadgets, and Dr. Obi rightly said that. He said it's not just about gadgets. It's not just about bugging people like, oh, I live in a smart house and these are the things that my house has, and things like that. No, it's not just about that. It's also about, adaptability, being proactive, being responsive, being human centered. So designing with identity in mind, decoding the client's lifestyle, the values, very, very important. What are the behavioral needs? What are the cultural needs? Sustainability, like what are the things that this particular space really needs? Designing for emotion and the senses through light, sound, and movement. It also means smart tech as wellness and enhancers. It also means creating harmonious and relaxing environments, white noise for people who don't want or who want to concentrate, ambient sound, ambient lighting, interiors that provide solutions to stress and promote calmness, for people who, they just had like a very long day at work. I've come back home and I want my space. How normally people would go and check into a hotel to be able to relax and all of that. With the innovation that is going on in the interior design industry now, and the fact that a lot of homeowners are inculcating, and making use of design and tech for their own, personalized designs, smart designs. There will be it won't be in a situation where you have to leave your house to go and enjoy anything that has to do with home away from home. This will now be home away from home in the home. That's what it becomes, because your environment understands you. Your environment is built for you. So you have clients with environments that understand them, with environments that are built for them, environments that take care of their sensory, psychological, emotional, mental, professional, productive needs. Next slide, please. So this is what it means to actually create, or should I say design for modern people, and to keep, that interconnectedness between the devices within in the house should actually not just be for trends, not just for trend setting. So design and tech, a combination of design and tech, a lot of people who don't really understand, when it comes to efficiency, and also design, managing all the other parameters, in design. You have to think of your costs, you have to think of sustainability, efficiency, productivity, all of that, not just for the design, first, before you now think of, so it's like marrying all of that for the design and then marrying it for the user as well. So it means that the future is responsive, the future is reflective, and it's also rooted in humanity, right? So designing for modern people, with all the interconnected devices just means a responsive, reflective, and human-centered, design. Next slide, please. And so it just means that, for the industry, it's not going to be about just, using these tech tools to make other people feel like, oh, this is what we have in our buildings. No, it's about saving time for people, about reducing energy. These are the benefits really of smart tools. Smart, when design and tech comes together, these are the benefits of smart homes and smart designs. It's family. It increases, family moments. Decreases stress. The energy is reduced. Time is saved. Um, it has environmental impact as well. So it lowers the environmental impact. So, for example, you are going out and then you forget to turn off the lights in your building. You turn it off when you go, or you already have sensors within your building. Once you step out and you close the door, it's already programmed in such a way and automated in such a way that once you have left the building or you've left the room or something, like everything goes off. If you've been to, the modern hotels, right now, you would realize that, the security and even the light and all of that is already attached to your card. So once you remove your card from the slot and then you step outside of the room, everything goes off. So I like the efficient, part of smart designs, and all of that, but much more than just it being a tool for all the benefits, all the architectural, engineering, and construction benefits. It's very important for us to also use these tools, use our design considerations, use design and technology in a very innovative way that helps to solve problems for the user of these buildings. Because what is a smart home without it being tailored or personalized to the user of the building? It's always interesting. Imagine that somebody comes into the house is just built and just everything is integrated. So finding that sweet spot, right, between designing for designing, designers using all our experience of design, and then technology, where design meets technology, but making it, ensuring that it is actually human centered. It is built for people. So we're designing with identity, with culture, we're designing with sustainability, with inclusivity as well. Let's not forget about inclusivity. In everything that we do, we have to think about, people who are differently abled or disabled and things like that. So people with their own different personalizations or different needs, let me put it that way, would have different needs when it comes to smart homes. But smart homes is good that it has all the there are so many things that are available, with smart homes. But the smartest home, I believe, would be the one that would be smart, soul centered, the one that actually responds to the needs of the people who live in that building in a way that it enhances their behavior. It also influences, them living and behaving a certain way, changes and influences the lifestyle, makes the environment more optimal, more efficient for the users of that building. It is intentional, it is intelligent, it is global. So this is what the future of smart homes and interiors is like. It's like a sweet spot between design, technology, and human-centered design. And with that, we conclude this presentation. Thank you so much for having me. You can send in your questions to the JD team, and then we'll take them when it's time. Thank you so much.
Meet architect Akinwale Arokodare, who will be speaking on artificial intelligence and machine learning in architecture, engineering, and construction. Akinwale is passionate about the fusion of art, nature, and technology. He strives to push the boundaries of innovation by nurturing self-expression and creativity. As an architect with over 10 years of experience, leveraging technology to enhance creativity is a topic he is passionate about. Currently, he is working on using AI, artificial intelligence, for world building. and creatives have a huge role to play in creating immersive digital worlds. He also regularly writes on topics around creativity, design, technology, and artificial intelligence.
Evening, everyone. My name is Akinwale. First of all, I'd like to say thank you to the JD team for putting this together, and also thank you to the various speakers who have shared their insightful presentation and knowledge. It has been interesting. I've learned a lot. I've met some new people, seen new faces. I've also met people I've known in the past, and it has been really interesting. So I'll be talking about artificial intelligence and the future of modern architecture and design. So, talking points. What are talking points that I'll be running through? I'll have a short introduction where I'll talk about the new age that we are going into, and I would also talk about the history where we are coming from, and I'll talk about the future opportunities in terms of how this new technology is going to be integrated into architecture, real estate, and design. Although I noticed a lot of speakers have sort of highlighted this issue like smart homes, um, um, twin design, um, construction, like we talked about, and constructing buildings that have complex forms. So I'll just run through it quickly. Just a brief history. I studied in Covenant University. Right now, I work in Mixta Real Estate, a real estate company located in Nigeria, Victoria Island, and yeah, and I'm passionate about architecture and artificial intelligence. So let's talk about the evolution of architecture, where we are coming from. If you look at the picture on screen, you can remember some time in the past how architects used to work. You know, we would be in our studios working on this large technical drawing board, and we'll have T-squares, we'll have different pens, pencils, and we'll be drafting building designs on paper. That was where we're coming from. And we kind of evolved from there, and we started using computers. We started using AutoCAD, Revit, and the likes. Then um, you would notice now that there is now somewhat of a shift. We're kind of moving into what we call like a much more intelligent age. So you can now you're hearing things like virtual reality, um, immersive design, and the like. So that's kind of where that's the kind of change that has been happening over the last, I would say, 25 to 50 years. So let's look at, and one thing you would notice is as technology changes, the kind of buildings that we build changes, the kind of architecture that you see changes. You would look at in the past, look at an example of a building like the Pantheon that was built in the 1700s, located in France. The style was neoclassical. So you see that it has a lot of stones, elements, massive pillars, and monuments and ornaments around the building. Because then we were not using computers, it was more of manual labor. You have a lot of craftsmanship involved in the execution of our buildings, of our architecture. Then you can now move on to the 1900s. You can have an example of a building like the Casa Battilio, which was designed by Anthony Gaudi. It was more of the Art Nouveau style. That was when there was more of a lot of artistic expressions in the buildings that we designed. So you would have buildings that had a lot of artistic character. So, for example, if you look at the picture here, Antonio Gaudi's building, you see how the building has a lot of elements, like as if there's a form of language on the building. So when you look at from where we're coming from, the Pantheon, which had straight lines, ornaments on the building, to the Casa Batilio building, which moved from 1700s to 1900s. So 1900s, you see more artistic expressions and the like. So you can see the huge change in terms of how we designed our buildings and the kind of technology that we had at our fingertips. Then you move on to further down in 1900s. You see an example of a building is Falling Waters by Flank Road, right? You can see a lot of cantilevers, but then we found a way to understand how concrete works, and we found ways to integrate our architecture with the natural environment, integrating this building, for example, with the waterfall in that environment. That's when we started hearing things like modernist architecture and the likes. You will see now that there is less form of artistic expression. There's less form of that craftsmanship where they are molding ornaments on the buildings. All those kind of things kind of faded away, and now you're having more of straight lines, brick facing, cladding, large windows, metals, stainless steel, and the likes. Because we've our technology evolved from the era of the 1700s to the era of using computers. Then we move forward to the 20th century. Then you will notice that we started to build higher buildings. We started to build buildings that were more energy efficient, because we realized that they were consuming a lot of energy. Then we started to integrate elements such as glass and steel in our buildings. Then we started to integrate a lot of computer elements into our designs in terms of smart homes. So that's when you now start hearing things like contemporary design and modernist architecture. So we've gone through how we can see how as the technology changes, the building changes. So where are we kind of going towards? Where are we evolving to? We understand that as the evolution of the technology changes, there's also an evolution of the architect, and likewise, there's also an evolution of architecture. So this new age that we're going into, a lot of people have called it different names. Some people call it the smart age, or when you read text from scholars that work in OpenAI and Google DeepMind, they call it the intelligence age. So because it's an age whereby computers are much more smarter, but not just computers, human beings, their capacity to produce content, architecture, or any form of self-expression is much more efficient due to the tools such as artificial intelligence that could improve their creativity and productivity. So that's what the intelligence age is about. Explosion of intelligence. And that is, if you look at the presentations from all the speakers, you see the professor that talked at the beginning, we talked about creating twin cities, looked at the complex building, that building that looked like a closed lotus that the first speaker talked about. You can see how he was using technology to create a building. So you can see that there's a shift in terms of how we are coming from the Pantheon to Falling Waters to the age of the Art Nouveau, and we're now going into the intelligence age. And this is going to reflect on the kind of buildings that we design and build. So I just have an image here, and it just shows a lady. She's holding a bow and arrow, and she's about to kind of shoot the arrow. And what I want to use this image to kind of represent is how this technology that is kind of changing, how it relates to us as architects, designers, builders, and professionals and the like. Now, that woman is maybe the professional. Now, that bow and arrow is the technology. So I just want to I want you to have this in mind, because this technology is becoming powerful, is exploding, is changing every day. It's changing very fast. So always have it in mind that this tool that you have is to help you achieve your goals. You should envision it that this is a tool, whether it's ChatGPT, whether it's Claude, whether it's TestFit, whether it's Gemini, whatever tool that you are using to help you express your architecture or your design, it is a tool. When you start to put yourself underneath that tool, there is a problem. There is a problem in the process flow of self-expression. So all this is a tool. If it's artificial intelligence or super general intelligence or AGI or whatever, it's a tool that humans should use to push the boundaries of creativity, of construction, of project delivery, of project management, or the likes. So all these are a tool. So if you look at all the speakers from the first speaker, they talked about how we humans were using this technology as a tool to. So just put it in mind going forward. So let's look at a timeline for where we're coming from and where we're going. You can see at the left we have a picture that kind of depicts the agricultural age. That was the time when we used to work on farms. We're more of make a product and transfer it from the farm to a populated area like a city. Then we moved from there to the industrial age, where we're having a lot of factories around the earth. So there was a lot of manufacturing in the industrial age. We had a lot of maybe like textile factories, plastic factories, clothing factories and the likes. Then we moved from there to the information age, which we are currently kind of in, where there was an explosion of digital devices. So if you remember how I said we used to work on paper before, then we now moved to using tools like AutoCAD and Revit. That is somewhat in the information age. So now when we are transitioning from that into the intelligence age. So you can see now that there will be a larger form of technology used in this age. So I just put a question mark there to kind of pick our brains on where we are transitioning into. Then I will just explain further so that we have an idea of the various where we're coming from and where we're going into. Now, if you look at this screen now, I have like an outline of what makes up these various ages. Now, the industrial age, we had mass production. We used to humans used to produce a lot. Then architects were craftsmen. You had a lot of sculptors being architects, artists being architects. During that industrial age, there was division of labor. There was a lot of rise in factories, and we're producing things like iron and steel and stones. Then there was a lot of coal and energy use. Now, in the information age, which is about 1900s to 2000s, we had explosion of digital technology, global connectivity. You could be in Nigeria and you could communicate with someone in the US. There was a lot of e-commerce. People started selling things online. We had the rise of companies such as Amazon, Yahoo, Google, and the likes. Then we had the introduction of smartphones, where you could use your phone to communicate and do a lot of things. So now, this age that we're currently entering into, which is by the right, which is called some people call it the intelligence age, some people call it the synthetic age, some people call it the integration age. We're going to have a lot of things such as clean energy, advanced robotics, artificial intelligence, automation, and other things such as wearables, technology, and the likes. So, having that in mind, what does it mean for us as professionals, as architects, as designers, as interior designers, as engineers. What does it mean? So I sort of prompted AI to kind of ask AI that question. Now, if you look at the screen, I have a comment from OpenAI, that's ChatGPT. It says that this age, therefore, is defined by a profound shift towards high technology and sustainability, with a focus on enhancing human capabilities and environmental stewardship. So I've highlighted there the key word, which is profound shift towards high technology. I also asked Gemini, and it says, it is a proposed era following the information age characterized by the increasing interconnectedness and blurring of boundaries between different spheres due to technological advancements. So I also highlighted the keyword there, technological advancements. Then I also had Claude, and Claude said that the integration age will be characterized by the seamless integration and convergence of various technologies, data, and systems that have been developed and advanced during the information age. So, what do these three AI systems, what's this definition of where we professionals are going into? What is the common theme there? And we have it on my screen there, just two words: advanced technology. It is what has been kind of ringing out loud. If you look at the presentations from the last three speakers, advanced technology. That is, I think that's one of the major um, talking points of of JD team. They are always pushing how advanced technology sort of affects professionals such as architects, designers, and builders. So integration of advanced technology into everything. Like for me, like I said, I work in Mixter, so we're currently looking at how we can integrate advanced technology systems to improve our workflow, such as um, the stage one stage, the design stage where we're designing our buildings, or the stage two stage when we are creating detailed architectural drawings, or stage three stage when we are project managing our execution of our project. So we are always trying to integrate advanced technology. So everybody listening here, I want you, if there's something you take out from this session, listening to all these speakers that have spoken, you should always look at yourself and say, how can I learn more about advanced technology? How can I use advanced technology to improve my workflow? How can I use advanced technology to pronounce my creativity? How can I use advanced technology to improve my productivity? So those are burning questions that we should all have in our heads going forward into this new era that we are moving into. So we can just ponder on what has happened in the past in terms of what was advanced technology in the past, because technology would always progress, it will always advance. We had in the past, we had the innovation of products such as computer system, the telephones, penicillin, light bulbs, automobiles, and the likes. Now we are at a stage whereby there is artificial intelligence, brain-computer interface, nanotechnology, and there are a lot of things coming up. And yeah, we are to introduce and integrate those advanced systems into our workflow. So how we as real estate professionals, architects, builders, how can we take advantage of this coming era? How can we integrate it into our workflow? I've created a list here, but I think a lot of speakers have spoken about most of these things. I think our last speaker talked about my first point here, which is smart homes and smart infrastructure. So one ways that we are kind of integrating this advanced technology is incorporating smart technology. Second point, energy efficiency. Architect Paula really talked about that. We're also looking at Internet of Things and devices for controlling temperature, lighting, security, and likes. So that is smart technology. And if you are conversant with smart technology, it's an ever-changing field. Like for me personally, I can't say, okay, I've done a house and it's a smart house and that is all. And if I'm going to construct a new house, it's going to be the same equipment that I put in my last smart house that I'll put there. It wouldn't work that way because it's always evolving. If I design a house with a particular lighting system that maybe there's a phone that controls the lights, before you know it, there'll be an upgrade. There'll be a version 1.1 or 1.2 because of the way technology moves. So that's a very key element in terms of smart home and smart infrastructure. The the constant upgrade of systems. Um, I have in front of me a HP laptop and is running on Windows. Now, in about maybe by the end of the month, Windows is going to send a new software upgrade, which you would have to download, update, and upgrade your system. So, something about smart home systems or smart infrastructure is that there are two components: there's software and hardware. That's when you think about technology. So when you're integrating those systems into your building design, you should always keep in mind that software and hardware always goes through upgrades and changes. So you have to think about how it affects the kind of buildings that you design. Then we have virtual and augmented reality. Those are things like in my office, we've started integrating into our workflow in terms of for example, we launch a product here in Lagos where we build an estate, and we realize, the people who are buying this our product, this our estate, are not in Nigeria. We noticed that a lot of them are based in the diaspora, in countries such as Canada, US, and the likes. So we kind of created like a virtual reality of the estate. We gave a particular vendor who modeled the estate, something Architect Obi talked about, where he mentioned about a digital twin that they created New York City for the Spider-Man movie. So we created something like that, where we modeled the entire estate and the individual buildings, the road networks, the, the trees and the likes. And we created a system whereby people who in USA, Canada can log into our portal and wear what they call virtual reality headsets and visualize the estates like they are there. They can walk into a building, walk into the room, see pictures, see images, see videos, and kind of take them around that estate. So that's sort of technology bridged the gap in terms of linking us with potential homeowners and clients that are not within Lagos, Nigeria, but are somewhere else in the world. So that's a way we've kind of used advanced technology to sell real estate and kind of advertise the architecture and the designs that we are selling. So we also talk about data analytics and AI. A lot of us here have started using AI. We've started using tools like ChatGPT, Gemini, and the likes. One thing that AI is very good at is data, managing big data. If you were to give a PDF of about 100 pages to the smartest human, it will probably take him some time to go through it, to analyze it, to review it, to come up with constructive criticism on that particular form, that document. Or if you give AI, it takes it seconds, not up to a minute, to review it thoroughly. So data analytics. It's very good when it comes to this new technology, this artificial technology. And I can give you an example of how architects use data analytics. An example is my office. We had a project whereby we were creating a master plan that had a lot of plots where we've designed the plots into 300 square meter plots, 900 square meter plots, and we've carved out a lot of plots in a master plan. So our task was to give without AI, we would have given a younger staff, okay, this is the layouts. Can you count how many 300 square meter plots are there? Can you count how many 900 square meter plots are there? Can you note the plots that have a view to the lake? Can you note the plots that have a view to the gardens? You know, those kind of things. It would probably take an architect maybe about an hour or two to review that. But with we used Claude and ChatGPT. We gave it the layout. We put it in PDF. We gave it the layout. We uploaded the layouts. We prompted it the same way you would have given an instruction to a junior architect. We gave it as prompt to AI, and within seconds we had a full detailed list that we can export to Excel spreadsheet of the number of plots. It even puts noted the plots that were facing garden views, that had lake views, and the likes. That was how we were able to use AI to analyze that data efficiently and at phenomenal speed. Now, we also have integration of health and wellness. One thing we've noticed, because I work in real estate, and one thing we've noticed is that we've had a lot of clients right now are really concerned about health. There's just something about health and wellness that is kind of gaining momentum now. If you are in the industry, I think it's maybe due to the rapid changes of technology and I think stress levels. So that a lot of clients are really concerned about health and wellness. So what we realize right now, if we're launching maybe an estate, we always ensure, oh, there's a gym. Clients want to know if there's a gym. If homeowners want to buy a house, we notice that families, they always try to buy homes that have maybe a playground for their kids or some form of wellness activity. So it's like I'll call it a byproduct of technological advancements that's happening. It's just something we as professionals to just keep in mind, as that we should pay attention to health and wellness. I'll just leave that at that. Then we also have automation and property management. Because of the advancements in AI, automation is very it's like the cornerstone of integration of advanced technology. You have systems now that can automate a lot of things that we used to call redundant work. So I'll just maybe give you an example of how we automate tasks. Before we would scan. I'll give an example. If before, maybe when you want to create like a concept drawing where you want to send to a client. Now, what you would do is you would sketch a floor plan. You would now go to like a modeling tool such as Revit or 3D Max. You would model the building, model the walls, put in the windows. Then you now take it to a rendering software, maybe use V-Ray or Mental Ray or the likes to render it into an image that would kind of conceptualize your idea so that you can share to a client. Now, if you look at that workflow can take you a week. Now, because of automation and AI image generation, you can describe what you intend to create and give it to a AI software. Currently we use Leonardo AI, we use Prom AI and MNML AI. And these systems would give you images that would somewhat about 75 to 85% capture what you have in mind. And that would probably take 5 minutes. And you can take those images and give it to your client and present. So it's has kind of sped up the process of projects delivery for us as professionals. Then something that we are also kind of taking advantage of is vertical communities, co-living and co-working. Now I'm going into details of this is some of like a real estate item in the sense that what we've realized in our profession is that land has somewhat become expensive That's on one hand. On the second hand, the spending power of a lot of clients, a lot of people in the market has somewhat reduced. That's on one hand. On third hand, we notice that technology is advancing. I've spoken about advanced technology. Then, when you put these three things together, we realize, okay, we would need to go up. Now, when you are going up, you have to think about things such as the foundation of the building, because the higher you go, the much more depth your foundation would have to be into the ground to support the weight of the building. So, if you look at advanced communities such as China, Singapore, and Beijing, Japan, you would notice a lot of their cities that are populated, the buildings are going higher to integrate the city system into a vertical structure. So this is the direction real estate companies and architectural firms are going into, especially those that reside in countries that are highly populated like us, Nigeria. So this is a direction that we will probably go to in the future. So for us in real estate, we are constantly researching on these elements. We're looking at new building materials that can make our buildings much more efficient in terms of bringing in all the elements. So if you look at a city, everything is spread across the land. The hospitals are in one section, the residential are in one section of the. Then you have road networks. Then you have green elements spread across the land. So we're currently looking at how we can bring all those elements into one structure, go upwards towards the sky, make it multi-level, and make it functional. So those are vertical communities, and those are the things that we are currently driving towards as a result of advanced technology. Then we have other examples such as biophilic designs and high-tech materials. Biophilic designs is integrating elements such as green facades, green terraces, and the likes into your building, so your building kind of reads. And high-tech materials. So we're going to notice a lot of new materials being discovered and developed as a result of advanced technologies such as AI. If you read about what's currently happening, you will notice that Google, they just created what we call this quantum computing system that is a million times more powerful than our current computer systems, and it has discovered new materials from the various materials that we were not really used to in the past. And that is one of the advantages of these advanced computer systems. They will develop and discover new materials. So we call them high-tech materials. So as professionals, I think we should I always tell my colleagues to always read, research, and be on the lookout for new materials that we can integrate into our buildings. Now, we also have systems such as neuroarchitecture and community-centric designs. Neuroarchitecture is it's an emerging field of an architecture that involves designing environments based on how they affect human brain and emotion. So you have to think. I think the last speaker, Folakemi, talked about how your interior space can affect your mood, and how you design the interior of a building can affect how people even interact with each other. So we have to go into the nitty-gritties as architects of how our buildings affect people, affect creativity, affect productivity. Because when you look at how we've been designing in the past, you don't want to just, brick and mortar. Let me just do a box. Let me just put a roof over the box and just open it up and let human beings live. No, we have to go into the nitty-gritties of how that building affects people, how in terms of the energy, the savings, the daylight system, the wind position. And so we have to go into those little details on how it affects the human brain and emotions. Then we also have community-centric designs. Remember I talked about how our buildings, a lot of people are going into, are really concerned about health and wellness. Something that we also notice is community-centric designs. Now, when advanced technology technology is advancing, you can see it how there's internet boom, technology boom, social media. One thing that happens is that a lot of people, they depend on this technology. It affects their life. Then the community social element of humans is somewhat I would say ignored, because most of our time we're on our phones, we're on the internet, but that relationship, that social interaction of humans, we kind of ignore it. You know, before as kids, we used to play outside, we used to meet people outside when we were on the fields, when we were on the streets, rolling tires. But now a lot of people are indoors on systems, on computers, watching Netflix on their phones. So this is something we've noticed in real estate. So we always ensure that when we are designing our estate, it is community centric. So we design in such a way that the people who use that building will somewhat have some form of social interaction. There will be some form of community. So those are the kind of things that would make, as architects and professionals, that will make you stand out in this new age that we are entering into. So it's not just about brick and mortar now. It's much more deeper than that. So let's just briefly just talk about the elephant in the room, which is artificial intelligence. I'll just say that yes, a lot of us have been using this tool now for like the last 2 years since it became mainstream. But I will tell you for a fact that AI has always been in production in terms of researching about it, creating prototypes from the 1900s. What I have here is the first machine to human communication chatbot. Just like now we have ChatGPT, which started as a chatbot. We had one developed in 1960. It was developed by an MIT professor. It was developed to be a therapist. That's 1960. That's close to about 70 years ago. That was when the first AI chatbot was created. So I want you to just have in mind that this technology is not new. It's been in development since the 1960s, and it just became mainstream in society. So we know about ChatGPT. We know about OpenAI. I'll just talk about it briefly and talk about how, as architects, it is something we need to integrate into our system. I have here a quote from Sam Altman. I'll just read through it and just talk through it briefly. He says here that it's a reminder that predictions about AI are very difficult to make. Now, he says that a decade ago in the past, the conventional wisdom was that AI would first impact physical labor and then cognitive labor, and then maybe someday it would do creative work. But now it looks like it's going in the opposite order. So I'll just talk about this paragraph. When in the 1960s, when this AI was being developed, when we had a lot of people, scientists, engineers, and technical people in technology companies developing AI, their plan was that when they released this into society, it would affect physical labor first. Physical labor, what is physical labor? Physical labor is maybe carrying things, using your physical body to engage in productive work. That's physical labor. So they always thought that robots was what was going to kind of like get into the system first. But if you look at what Sam Altman said, he said it is going in the opposite order. So it is starting with creative work. And creative work kind of falls into what we as professionals do, we as architects, we as interior designers do, we as builders. So you would notice that it is being used right now in things such as image generation, analysis, and even other creative works that we do in our office. So we are like the first users of this advanced technology, and it serves to sort of ignore the many potentials of this advanced technology as professionals. So let me just talk about the drawbacks and challenges, because I don't see a lot of people just talk about, oh, let's use this, let's integrate it, but let's talk about some drawbacks and challenges. So number one I have here is over dependence. So um in my office we use AI, but what we've noticed is there's some form of over dependence. So I would always advise people not to fall into that trap of being overly reliant on chatbot use, on generative AI use. Always ensure that you somewhat express your own creativity. Because if you understand the concept of machine learning, which is the cornerstone of how artificial intelligence works, machine learning works by um, um, consuming large amounts of data. It consumes large amounts of data, then it finds ways by using algorithms to generate potential outputs to the prompts that you give it. So I'll just explain this. So if you give an AI system somewhat various images of architectural designs that were created by Zaha Hadid that it should learn from. So if you take all that as data, consume it. So when you want to prompt it to maybe, design an office building for me, that's the prompt you're giving it. Now, if you take all that large amount of data, which is buildings designed by Zaha Hadid, and it would try to answer your prompt. Okay, it should try to answer your prompt. So over dependence is a major issue. So those are the drawbacks. I don't want to run through it. I'll just run through some AI apps that we currently use and how we use them. For image generation, we use Leonardo AI. For architecture, we use Prom AI and MNML AI. We use that in our office to create architectural images. For word processing, we use Gemini, ChatGPT, and Claude. And for our real estate designs, we use TestFit. So thank you everyone for listening. If you have any questions, feel free to reach out and ask and put in your questions in the chat box.
Meet architect Okolie Uchechukwu, who will be speaking on virtual and augmented reality, AR and VR, in design and construction. He is an architect based in Lagos, Nigeria. He is also a 3D artist, 3D animator, and programmer. With his knowledge in programming and being one of the top architectural visualization artists in the country, Okolie Uchechukwu has developed programs and real-time interactive software that create an unconventional method of space exploration. He is the principal partner at Clique Designs, a firm with an exceptional eye for detail and realism. The firm provides top-notch 3D renders, 3D animation, and interactive applications for real estate agencies, construction firms, architects, and developers. Okolie Uchechukwu is now fulfilling his teenage dream of creating his own game. The game is called
Okay. Hello. Okay. Good evening. Good afternoon. It's actually nice to be here today. Um, it has been a long day. I have been waiting waiting for my session. Okay. So today I'm here to talk about virtual and augmented reality in design and construction. Yeah. So like the previous said, I am an architect by profession. That's what I studied. But what I focus mainly now on is being a visualizer. That is, I do 3D images, 3D animation, and some form of coding. Um, like um, like the first picture, it just shows a 3D image of a building in Lagos on an island. As in, this 3D render was done when the building was still doing the power foundation. So we kind of showed the way the building would look like when it was built. So this image was done some years ago, and the building is almost finished by Sojimoto. The next image just shows a brief animation of what to do, and the last one shows the game we did, and also the apps also do. So we do apps also do games and all. Yeah. So that's that's just me. I visualize mainly. That's where I focus on. So we have the next slide. Okay, so now why VR AR? Why does it actually matter? Um, it matters now because the normal 3D images and videos we do are kind of no longer enough. Whenever an architects do whenever we do our designs and which kind of show the clients, sometimes the images, even if you do really good vendors, are not enough for the client. They usually want to see more. So that's why AR and VR, they actually matter in the contents of things nowadays, and also because it makes the whole experience more immersive. So it helps if when designing, you can actually do a real presentation in which the client can go go through a space and ex, experiences this instead of normal 2D images and all. So that really helps. Okay. Okay, now it's the next slide, please. Okay. So I would want to explain the meaning of AR and VR. Um a, the VR VR for VR first is mainly creating a virtual environment and using a headset to view it. While AR is when you actually use your phone or a tablet and use the camera, and a 3D now is now used superimposed on it. So that's the simple difference between AR and VR. While MR, is it XR, which is mixed reality, is when the headset utilizes a camera, and then and then you can see through. Now, um, the role of AR, the VR in design and design and construction. Um, First of all, it helps with better visualization, especially in design, because the difference is is clear, and it is better than the normal 2D renders or the two two 2D animations that is done normally. So but by the time you see a 2D render, you see what VR and AR can do. It's you can't really compare two of them, and and also it helps to make the clients approval faster because one thing that delays the design and construction process is the fact that whenever the clients most of the time don't really understand what's been drawn. So the architect might design, he would design something that he feels most of the time a normal person should understand. But sometimes there's this back and forth. So it actually helps to ease that process. And once the client understands what you're doing, then he can make the right feedback in order to help the process move forward. It also helps on site in terms of when you're on site and the artisan sometimes the back and forth with artisans. And so if you have an AL setup in which you can show the artisan the way things are meant to be installed, how things are meant to be done, it will help the execution process and all and also it is used for training and simulation, which uh, I have personally not tried out, but I know it is. Benefits. I guess I explained the benefits in just what I just described, but I'll also go through the slide and explain one after the other. So, like I said, it helps the client to understand the space better and faster, as in it can be, as in it just helps the client to understand the spaces faster because so like I said, the 2D and 3D presentations uh, can't can't be compared. And it also helps you to remote presentation so that like the speaker before me said that sometimes you can just send the file to them and they can view it from wherever they are. So it helps. And also the approval cycle because once a client understands your an architect and a designer is able to transfer what's in his head directly to the client or to other people on site as long as they're able to understand, it helps. And also the cost reduction because um even me as an architect when I do my renders I get the 2 days as in base is actually what I do, what I studied. Sometimes it's difficult to interpret the line drawings that you get from fellow architects. So if the presentation is done in 3D, it helps and helps out. Okay, now what are the challenges in Nigeria? One thing I would say is the cost of the headsets because when you're trying to pitch the idea to someone on the importance of doing this within your workforce within the office and you now have to tell them the cost of the headsets and the software and also because the VR headset will have to be imported. Like this morning, I actually checked the cost of getting headsets between 5 to 1 million, and that was just one 500,000 to 1 million naira. That's that's just for now. For a presentation, you might need one, two, and there's also it's not just the headset. There's a PC to set up, and there are there are other costs, and well, that's just one of the challenges in the country. Power also, because you will need to run to, or you will need that to run whenever you have the presentation. Before there, there's the VR headsets that work with phones. That that was really helpful. But now the support for that and via the software have dropped. So that's so that hasn't really helped. Um, Also challenges resistance to tech in Nigeria. Traditional settings. So there's really in terms of that, you really have to show that what I try to present in terms of the whenever I have to try to present an app to someone, I have to try to present to let them know that it is worth it, that you save money and you make money. That it helps your presentation. Though most of my clients mainly have real estate firms, so it's like do this and you will see the result when you kind of present the project in a better way. So that's just what we try to do. Though the progress is slow, but we are getting there. We are getting there. We are getting there. Um, okay, next slide. Okay, now what you have here is the sample project I worked on. I was called on the initial stages, like the stage in which I work on. I'm called on for most of the projects is when they're actually here to start filing, and which you want to start doing the presentations, trying to get in investors. So this project is at Echo Atlantic. They have almost finished A, and E tower by Auckland. So the project is practically finished. So from the onset, when they were still they were just done with the architectural drawings. I was called in, and I did a VR presentation to help the marketing team mainly. I guess, and I did images, renders, videos, and also the interactive app. So at the end of of my presentation, I guess there will be a video played to explain the way the app that we use mainly. That's what I present. Okay, so the video will be played now so that you understand the way the app works.
Real-time interactivity by Click Designs. Marketing a property that hasn't been constructed can be a challenge. Here at Click Designs, we have created a sales-focused application that allows investors to explore projects before they are constructed. The application, available on PC, mobile devices, and through virtual reality, provides an immersive experience which creates a more holistic understanding of what the building will look and feel like in reality. It is more cost-effective to make changes virtually than when it is built. These changes that allow the end user to create a more efficient space that fits their needs. Contact us today so we can create real-time interactive applications for your projects.
Okay, so that's if you watch the video, if you watch the video, you understand changes was said a lot, because when a building starts from when the client thinks of it, the person that is going to cover the cost till when it's finished, I bet close more than 100, if I wanted to say 1,000 changes that happen during the design process till it gets to to the end, especially for those kind of high value buildings, and especially when by the time they even start, it depends on the kind of buyers they get. Each buyer might want his own space design in different ways. So the changes are continuous. So if you have a seamless process to kind of show to the client what the space will look like when it is built, and that can be transferred to the prospective buyer, it helps. It saves a lot of cost than building breaking walls and all and all that. So what's my final thought on VR and and AR? So sometimes they feel like the idea is just a trend, and though the tech has been changing since the thing about tech is it keeps changing. Then it was VR and AR. Now it is AI that we're trying to, but they are all different. So it just keeps changing. It's just that as it changes, you have to update yourself. So it is going to happen. So it is either you accept it now, or the one thing I always pray for. I always try to update myself, so I am not called old school. I'll be here for a while. Okay, so the other advantage of VR and AI is that you get to experience the space in full. As in, it is not just one tool. You don't just see a tool a small direction and a small camera angle of a space, or even do the animation. There are limits of what you can show. But as a designer, and when you there are some spaces I work on, I'm like, well, I just have to work on the whole thing, even though sometimes the client doesn't pay me for that. I just appreciate the fact that creating this, I just have to work. I work on the whole thing because it's just fun. And the next thing, the last thing I said is that clients nowadays want to see what they're buying into. They want to see as much as possible, as many things as possible. So it now depends on whether you can like architect firms. The main architect firms that they work on every detail. Detailing takes time, but you have to finish, because firms and if an architect firm is that detailed that they are able to work on every detail, the furniture, detail the space properly, and then it's then transferred on site. It actually saves the client. And if after doing that detail, you're now able to present it through VR, AR to the contractor doing execution, it's the contractor would love you. Would be like would like thank you and be like saying, I hope I work with more people like this. So it is just the way it is. It is useful, it's helpful, and is a useful tool in architecture and design and construction. Yeah. So that's all I have to say. Thank you, and thanks for the opportunity to present. So my name is Okolie Uchechukwu, principal partner of Click Designs. You can check me out. Yeah, thanks.
Darwin's in Spanish, and all these other countries kick off the season and it's 90 degrees in their country. It's utter stupidity and a silly statement.
Look forward to reading that article.
I'm good. Because
Funny Augie, players at the team have learned some lessons about the heat.
right.
Learn what?
Did he not make FIFA?
Good evening, everyone. So we have our speakers in the house. We have Dr. Raul, we have Dr. Uwakony Obiora, we have architect Adetola Oyenuga, we have architect Akinwale. I saw architect Okolie just a minute ago. I'm sure he will join us very soon. We have some questions from the audience, and I'll be reading it out to us. Thank you so much again to the JD team for the double honor of presenting and then also leading this panel session with amazing professionals. The first question goes to Dr. Raul. To what extent have you been able to design and execute long span structures? This is from one of our viewers.
Well, I'm sorry. To what extent? What would that mean in terms of the span of the structure? We have reached over 200 meters in span, but I don't know if that is exactly the extent of the sense of the question you're asking, ma'am.
Yes.
And in terms of loading, which is also a very delicate subject, we have designed structures with very high wind regions, typhoon regions, etc. Okay, the examples I showed during my presentation were not exactly very challenging structural applications. They were more challenging in the fabrication and construction of the building itself. Okay, I don't know if that answers the question, but
I think it answers.
just please let
Yes.
me know. Thank you.
All right. I think it answers the question.
Thank you, ma'am.
Our next question will go to Dr. Obi, and Architect Wale can also jump in on this, but we'll have Dr. Obi first. How can firms and construction companies accelerate digital adoption? Is Dr. Obi here with us?
Yeah, I think it's mute.
Obi, the next question is
It's not mute on my end.
okay, we can hear you now, sir.
Are you hearing me now?
Yes, we can hear you.
Okay. You see, how can firms
And construction
come again with that
companies
question again?
accelerate digital adoption?
First of all,
Okay, how can firms and construction companies accelerate digital adoption? Yes.
okay. First of all, there are two sides of it. You look at the human infrastructure. You look at the infrastructure in terms of computing equipment. You know, for firms, they need to understand that it's not just being able to do have Revit, BIM, and just use it to prepare your design and do visualization. It goes far much beyond that. So firms should be able to train their staff in terms of to be able to understand how to use these tools. In fact, the level of digital fluency of design team members should be optimal in order to be able to use it. I know it costs money, first of all, to get the softwares, It also costs money to be able to get the computing infrastructure. It also costs money to be able to get resource persons that will train the staff member, the team members of that organization to be able to be up to date of the global best practices in terms of digital tools. When you look at digital tools, first of all, the idea is to be able to design optimally, being able to interrogate your designs in real time to be able to make better decisions, and also to be able to, prepare prepare for the construction stage in such a way that there is little or no rework at the construction phase. So the computing infrastructure is very, very important. The human infrastructure is very, very important, and now also the management of those teams should be able to be willing to invest in that area, because having a desire to upscale in terms of technology knowledge, it has to be matched with the financial muscle to be able to push you to the next level, because without that it will be very, very difficult. And at the same time, the firms need to be able to define their goals. How far do you want to go? Where do you want to play? At the lower level, or do you want to be able to compete with the best in the world? You need to look at it from that perspective, and they should be able to ask themselves, where are they in terms of the scheme of things? Are they expired already, or are they just scratching the surface? You know, there are some friends that you discover that they are just digitally, dumb. Some are digital stammerers and some are digitally fluent. So each firm should decide where they want to be based on their goals and how far they want to go with the organization. Thank you.
All right. Thank you very much, sir. Thank you. I don't know if Aktewale is here. Aktewale, please, can you also jump
Yeah,
on that?
I'm here. I'm here. I'm here.
All right. So,
I remember the question. I think I'll just add is that how firms and companies can integrate technology. A quick way is to look at your processes, your current processes for business delivery, for service delivery. If you are in a product delivering business, or if you're in a service delivery business, look at your processes. Now, try and identify those processes that you can sort of integrate some form of technological system that would make it either easier or faster or more efficient. I'll just give an example. Where I work, we have like a HR office, and what they do is that whenever all the staff members in the office, we usually go to the lunchroom, and before you eat lunch, you write your name on a form and you sign on that form to indicate that you've eaten for that day. Now the HR will take that list and they will give it to a particular staff, the operations analyst, and the person now types all the names of staff on an Excel spreadsheet that's eaten for that day, and they do that every day. So I was like, that's a process that happens in the office. So I was like, all you need to do is take that paper that everybody has signed on, scan it. Then we'll upload the scanned image. We upload the scanned image on Gemini, and Gemini now takes all that information and creates a spreadsheet. So you've given that staff member who would have spent about 1 hour on typing names, checking the spreadsheet, you've given that staff member another additional time to focus on more important business activities. So if you look at, as companies, if you can look at your processes, if it's conceptualization, if it's project management, look at those little processes and how can I use computer systems to make it either faster, easier, or more efficient. And you start integrating them into your processes gradually. Before you know it, you can now have them on a larger scale. So I think just start small and focus on those little processes. That would be my answer to that question.
all right. Thank you so much. Thank you so much. Thank you for that. Um, I'm going to move to Arc.Tola now. Arc.Tola, you talked to us about sustainable design. designing for sustainability, smart, designs but for sustainability. So can you shed more light on the return of investment? When one adopts a sustainable design, what's the return on investment? Because the person says it appears that the initial cost is very, he used this word prohibitive. So,
Okay. Statistically, it is not prohibitive because, IFC, the made Edge. I mean, the Edge certification system. International Finance Corporation is the one behind that, and like Lead is another one. But they're always advertising or encouraging people to use their certification system. And in that, their interest is to tell you the ROI. So they did their analysis and checked previous certified buildings. And that's, well, this example is from the US, over 5,000, over 30 years. And according to the statistics, the incremental cost on going green is between 3 to 7%. So it's definitely less than 10%. But if you ask people, ask anybody, ask contractors, immediately tell you it's 30% or more. Someone ran the research and said it is less than 10. You are using your expression and saying it is 30. Who should we believe? So if you then that's from someone running numbers. As designers, at the beginning of the project, you run the numbers, do your analysis, energy simulation, and everything, and turn the savings into numbers. Because once you get the energy efficiency, you can multiply by the unit rate and tell the client, if you do this design, it costs you so amount to implement this system, but from year 5, you start getting back your bills in terms of savings. And we did that. Julius Berger, initially, when Julius Berger owns Prime Tech, it's, and they did the building to be green. Decided to design and construct a green building. At that point, the solar panels installed, doing the calculating the ROI. That's why I put the numbers that I showed in my slide. Calculating the ROI then was more than 30 years, because then they were about showing experience and expertise in the technology and in design and building like that. So they were not really after but because of the increment in energy cost in Nigeria, the ROI has shrunk to, like, I think right now is less than 14 years, and the building is 11 years old. So in the next 3 years, they'll make back their money on the solar PV system. That's that at that point. Now, solar systems, I'm using solar for example, solar PVs have reduced in cost over the last 10 years to less than half of what it used to be, a lot less than that. So now a new person designing and incorporating renewable energy would have his ROI shorter than what we experienced in my office. So these things are not, there's no figure to it, but it's definitely lower than impression. And the final thing to know is on your own project, let the designers calculate and show you the figure in Naira and Kobo.
okay. Okay. So what you're saying is that so the initial cost, it might be capital intensive, but in the long run, there's a lot of benefit and they get everything back. So the ROI is it makes
Is
sense
low.
to
Yeah, yeah, it makes
actually
sense. And
go
just to add
green.
something that is free for anybody to use, you can also run your design on the Edge app and it will show you incremental cost. So you see it's less than a few years to get back the money for the incremental cost of going green. It's not a lot.
Right. Thank you so much, Architect Tola. This question is for you as well. Can you shed some light on the material efficiency of your proprietary geometrical space frame system, the geometrical space frame system?
Sorry, I think that's for Dr. Raul, but apparently I think it's off
Oh,
the. Yes, that's for Dr. Raul.
he's off the.
Sorry. Yes, it's
Okay.
off the.
Okay. All
So I
right.
think you
So,
can see that.
for Akinwale, so we'll wait. Yeah, when he comes on, then we'll ask him that question. Akinwale, there's a question for you as well. How can one learn AR VR? So this is someone who wants to tap into the knowledge. How did you get your knowledge, and how can one get it?
Well, it actually depends on what the person who wants to achieve at the end of. Let's say if it's an architect that wants to showcase their design, we have devices kind of directly connect to the software. So if you're using a bit of SketchUp, the headset, the software allows you to connect directly and view it. So you just need to research your software, this particular software you use, and learn how to connect it to the VR device. So the process is not really that it's not really that hard. It's just that you just need to get the hardware and the software there. So in terms of in terms of doing the actual presentation, let's say you want to present it to your client, it's just as simple as getting the headset and knowing how to connect it, and you can do VR presentation directly in your office without really having to call anyone else. So it is that simple. It's just if you're doing AR version that you have to learn either Unity or Unreal, which
All right.
requires some
Thank you so
little form
much.
of programming. Yeah, yeah, that's all. Thank you.
All right. Thank you, Arc.Okolie. These are the questions for now. I don't know if Dr. is not back here. Okay, so I'm going to hand over to you, Dr. Alalade, to just maybe wrap up for us for today.
All right, thank you very much. I think I want to especially thank everyone for your time, starting from Architect Tola Oyenuga. Thank you for your very succinct presentation. Architect B, I was hoping you were coming for an inaugural when I saw your 44-page slide. Thank you very much, sir. And by the way, Akinwale was my lecturer in the university some 20 years ago. I think he was the one that introduced some of us on this platform to Beam. He was a master of CAD, and CAD was running away. So the man quickly moved into Beam, and we were his guinea pigs. And thank you, sir, for your efforts and your labor over those years. I think if except for Okolie, the other four persons on this platform were your offspring. So thank you for that investment, and we appreciate it. I'm sure you're not disappointed at what we are doing. Thank you very much, and we appreciate you. And to Architect Wale, thank you for always eating our call whenever we call. Thank you so much. Architect Okolie, you are exceptional in your work. I told my wife, this guy that we are bringing in is one of the finest visualizations in this country. So she looked at me. She was thinking, "Oh, I thought you guys are doing." I said, "Look, this particular guy
Thank you.
you're bringing is one of the best." So thank you very much
Thank
for
you.
your work.
Thank you.
Your work have
Yeah.
inspired a lot of young architects, and so keep at it. And what Actor Folake, thank you, the only female on this panel. Thank you very much for your time and your quick response. By the way, Actor Folake got very late invitation and yet was able to deliver very well. And to our audience everywhere, thank you very much. It's been a fantastic conference in the last 2 days. Uh, we have a lot of information from our speakers. Yesterday we had Dr. Ani Fowoshe Azan. We had Samuel, the cybersecurity expert. We had Architect Opeyemi, fantastic architect, my partner at work, my colleague, doing very well. We also had yesterday as well. We had architect Tomin, not an architect. I think I've always made that Tomin architect already. He's an interior designer. Thank you very much for your work. They call her the interior tech queen in Africa. So well done, Tommy, from wherever you are. She's a Singapore, by the way. She runs a remote office in Nigeria and South Africa. Thank you for your work. Our other speakers yesterday want to say thank you very much. We sincerely appreciate all the inputs, all the time. Of course, Engineer Hani from Myanmar, thank you. Yesterday, you had a fantastic session on BMS, and MEP. I think this session this conference has been fully packed. A lot to learn from structure to architecture to interior to MEP to visualization. I want to say thank you to all our speakers and really appreciate you. And we hope that by next year, when we call you, you get our call. Thank you so much and have a wonderful time.
Thank you.
Thank you for the invite.
Thank you. Tola,
Thank
how are
you.
you?
Thanks.
Balake.
Good to
Good
see you
evening, sir.
again.
Wale, I'm now a
Dr. B.
granddad. I
Indeed.
appreciate you all. I appreciate you all. We should,
Nice
we
one.
should
Thank
be
you.
doing more collaboration. We
Yes,
shouldn't be
so
working in silos. It's not good.